Welcome to the No-Till Farmer Podcast, brought to you by Yetter Farm Equipment. I'm Michaela Paulkner, Managing Editor at No-Till Farmer. In today's episode of the podcast, contributing editor Dan Crummett talks with Michael Cully, the CEO of Susterre Technologies, a company developing a retrofit system for no-till planters that uses ultra-high pressure water jets to slice through residue.
Well, hello, I'm Dan Crummett, contributing editor for No-Till Farmer and Farm Equipment magazines, and I'm here today with Canada-based Michael Cully, CEO of Susterre Technologies. We'll be discussing a novel planting method that should interest no-tillers around the world. Michael, thank you for joining me today.
Thanks for
having me.
Tell me
a little bit about Susterre's work with water jet technology. Where it came from and what brought us to this point today.
Yeah, so Susterre, we were formed by a venture capital fund to commercialize a technology that's been worked on for at least 10 years now in the industry. We can talk about where it originated, but there was a company in Ontario, Canada that had been working on prototyping the use of ultra high pressure water jets. And by ultra high pressure, we mean water jets that are 60,000 pounds per square inch.
Yes.
So extremely high pressure. They're typically used in industrial manufacturing to cut through metal. And the theory here is that if they can cut through metal, then they can pretty much cut through anything you would find on a field.
Yes.
And what we're trying to do through the company is really promote the use of regenerative agricultural practices like no-till farming and cover crops. And to me, a little bit, I would consider the term no-till farming to be a little bit of a misnomer. I would almost call it delayed tilling, not no-till tilling, because there's really very few, if any, farmers that are no-tilling the same field forever. No matter what farmers tend to do is they end up tilling their fields every 3 or 4 years. And a major reason why they do that is because by definition, when you're no-till farming or using cover crops, you have heavy residue on the field. And as that residue builds up over the seasons, it becomes more and more difficult to cut through. And today's technology, which is either, a coulter or metal disc cutting through, a lot of times the residue doesn't get cut through cleanly. It gets pushed into the soil or hairpinned into the soil so that when the seed goes down, it's no longer touching soil, but touching residue. And that inhibits seed germination and plant growth there. So the theory is you take something like these ultra high pressure water jets, which can cut through metal, and they can pretty much cut through any residue that you would find on the field. And so that you can have farmers stay in no-till farming or stay in the use of cover crops for far longer. So we're not going to negate the benefits of no-till farming by tilling.
Okay. Well, how is this system adapted to planting equipment? The power requirements, water storage, plumbing, valving. How does that work with the system that you are marketing?
We are taking a technology in industrial use. It's a stationary technology that's typically used on a table to cut through metal. Right. And we're obviously putting it into a moving application in a field which has very challenging requirements. And so there's certain design elements that we've had to build into the technology to accommodate the movement of the jets across the field, even the movement of, if you think about putting the technology on a toolbar for a planter that might fold, you have to accommodate the folding and other things like that. So that's we have patented design elements that we've built in to handle that movement. It does require power to run the system. We require about 12.5 horsepower per row to run the water jets on top of what the farmer would need to run their planter. So you would a 12-row planter would require about 150 horsepower of of energy to run our system as well. We don't use a lot of water. On an average usage, if you think of a 30-inch spacing, moving at 5-6 miles an hour across the field, we only use about 10 gallons of water per acre. Okay. So really a very low amount of water. In fact, for farmers that are already using starter fertilizer, like a UAN 28%, we could actually use that fluid as the cutting fluid in our system. So in that case, the UAN would cut through the residue, cut into the soil, and then get injected into the soil about 3 or 4 inches, so below the seed bed. So it'd be waiting there for the seed, for the plant to tap into that fertilizer, which we think
placement just through the original pass with the water jet.
Right, exactly. So we're not using a lot of water. For a lot of farmers, if you think about the scenario of a 12-row, a farmer who uses a 12-row planter, is he normally going to have a 300 horsepower tractor pulling a 12-row planter? Maybe not. I would argue probably usually not. So what we are also offering for the farmer is what we call a power cart, where we have our own engine on the cart to run our system. It also serves as a fluid tank for the farmer as well. And then we also install on that cart what we call the intensifiers. Those are what pressurize the system up to 60,000 pounds per square inch. So you would have a scenario where the farmer would have his tractor, then the power cart, and then his planter behind the power cart. And we would install the row units on his planter that utilize the water jets there.
Okay. What would a planter look like from the ground engaging material if you go?
Right. So you would still see on the farmer the opening wheels, the seed mechanism, and the closing wheels on the planter. We would be at the front of the planter, and so we would be installing kind of a new little row unit. It has a kind of a ski on the front. Yes. That's so as we go forward, we kind of push down the residue as we go along. And then it has a nozzle that comes down and shoots the water immediately in front of the opening wheels on the planter. So our first product is a retrofit system that's going on existing planters. And we can install basically on any existing planter that's in the market. As you can imagine, no two manufacturers, even different models, have different configurations on the toolbar. So there is somewhat of a customization of where we place our equipment on the toolbar. But generally, the technology is the same. It's just where do we position certain items on the toolbar.
I'd like to take a moment to thank our sponsor, Yetter Farm Equipment. Yetter is your answer for success in the face of ever-changing production agriculture challenges. Yetter offers a full lineup of planter attachments designed to perform in varying planting conditions. Yetter products maximize your inputs, save you time, and deliver return on your investment. Visit them at yetterco.com. And now let's get back to Dan and Michael.
You mentioned the intensifiers. Are those electric driven, or are they displacement pumps? They're hydraulic.
They're hydraulic driven, okay. Yes. So our engine is running a hydraulic pump, which is running those intensifiers. An intensifier is almost like a giant tube. You can almost imagine like a piston moving back and forth inside a tube. And the movement of that piston is what creates all that pressure, believe it or not, 60,000 pounds per square inch.
Tell me a little bit about some of the agronomic benefits that you've seen in research demonstrations. Yes. I know there's a parallel effort going on in Australia, I believe with Aquatel, and I know it has. I've read of its use there. What can you offer the grower with this system?
Yeah, I mean, the technology originated in Australia. The Australian government was very interested in looking at ways because they're under extreme stress down there for crop conditions. From what we've seen, the aquatil technology is focused a lot on kind of special usage in that is slightly different than where we've been focused. We've been really focused on row crop planting applications in North America. And that's really where the development, we've gone through 4 rounds of prototyping. Plus this year we built commercial sized units for a final round of field testing. This summer or spring, we tested in 8 different field conditions across 3 different states and in the province of Ontario and Canada. And we tested, the results were really exciting with what we found out there. So for instance, we planted corn over heavy corn residue in Kentucky, for instance, and by mid-season, we noticed that same variety of corn, same population, everything, our corn was noticeably higher in height than where the farmer planted with his own technology. And we looked at that and said, well, that's strange. And we weren't sure if that meant anything or not. But when we did the harvest, we ended up having about a 6% yield increase over what the farmer saw. Likewise, we did some planting in double crop soybeans in Tennessee. So one day they harvested their wheat in June, and we went in the field the very next day and planted soybeans in that same wheat field. Again, a month later, they had a severe drought situation down there this summer. We noticed that our emergence looked better than the farmers' rows. And in all cases, we did side-by-side testing, meaning the farmer went down the field with his technology. We did the next pass with our technology, and we interspersed to make sure that we could see really side-by-side our effect. So in this case, with the double crop beans, about a month later, our emergence looked better. And then we had about a 9% yield increase in that field. And then in Iowa, we did a field that had the residue on the field was 2 seasons of corn residue plus a cereal rye cover crop that was about chin high when we planted. And again, our crop, the farmers told us our soybeans came up about a day earlier than his. The growth, again, we had a height difference in the canopy of the soybeans, and then we ended up having about a 12% yield increase over the farmer. So what we saw in those cases was very exciting in terms of going in extremely difficult conditions and delivering crops in difficult conditions. So there were 2 other tests that we did where basically we were able to plant in I would call unplantable conditions. One was in river bottom in Tennessee, where the ground was extremely compacted, not due to machinery usage, but due to flooding that they get every year. And it was over 400 PSI in compaction. When we planted side-by-side soybeans, the farmer could only get his seed about a half inch into the soil. That's how compacted it was. And we were able to deliver seed 2 inches, a full 2 inches into the soil. They ended up having to replant that field entirely. It was a total loss for the farmer, whereas we got we had emergence and growth in ours. Another one we did in Iowa was on CRP land that had been in the CRP program for 20 years. So you can imagine land that's almost like a meadow that had been sitting for 20 years. Unfortunately, the farmer, for whatever reason, that land was removed from the CRP land, so he decided to plant soybeans there. When he went out there with his own planter, he cracked the toolbar of his planter due to the horrendous conditions in the field. But we were able to get in there and actually plant a crop through his extremely difficult, I'll call it a cover crop. If a meadow can be considered a cover crop, that's what it was. And we were able to get in there and plant. And we're still waiting for the final yield results, but it was looking very good mid-season as well.
Yeah. Well, you've outlined being able to plant in an obvious good window, that sort of thing, and get the crop up to stand. What kind of other cost savings would a no-till producer you see from your technology?
Yeah, definitely. We believe that they will have some cost savings in terms of over applying seed and fertilizer in their field due to poor germination. Because we're going to have better germination than today's technology. In theory, the farmer could do a slightly lower population of seeds and still get the results out of their field because they're going to get a higher rate of return from what they do plant in their field. Also, because we can inject chemicals into the soil instead of on top of the soil, then we avoid a lot of that runoff from the field that where farmers are losing, the chemicals they're applying, which is bad for the environment, obviously, when you look at things like algae blooms and things like that. But from a cost saving for the farmer, it's an efficiency gain that they are no longer, whatever they're applying is going to stay in the field and be used rather than losing half of it to runoff or whatever they're losing today.
For everything you need to know about no-till farming, you need to make plans now to attend the 31st Annual National No-Tillage Conference being held at the Hyatt Regency St. Louis Arch Hotel. It's January the 10th through the 13th. All the experts, equipment, application discussions, workshops, and networking you need to get your no-till operation off to a blazing start in 2023. Learn the secrets of some of the highest yielding farmers on the planet. Legendary no-tillers like Russell Hedrick, David Hula, Randy Dowdy, Ray Archuleta, and many more. Visit no-tillconference.com and use the promo code RADIO for a $100 registration discount. Or you can call them at 866-839-8455 to sign up for the National No-Tillage Conference, January the 10th through the 13th, being held right here in St. Louis. Once again, that website, no-tillconference.com.
I noticed on the web you have some figures along that line. Can you share?
Yeah, we estimate right now that we probably could save at least maybe 10% on costs from planting. We also provide the farmers with a greater planting window than what they have today. One of the great things about the water jet technology is that it works extremely well in damp residue conditions. So today, where the farmer in the morning has to wait for the residue to dry out, or if it rains in the day and then they got to wait for that because they know they're not going to be able to cut through damp residue, as long as a tractor could be in the field, we could be out there planting. So we literally could give more time to the farmer, which, as you know, in a 10-day window, say every hour matters. So if we can give them more time, it's at least a risk mitigation factor, but it could mean that they could actually plant more acres each day than they could today. So that's a revenue opportunity for the farmer in that case as well.
Walk us through a discussion of Susterre's sales pitch, so to speak. Convince a grower that they need this.
Yeah, no, I think what we're seeing is based on the results that we're seeing on yield, the more efficient use of inputs, the ability to have more time in the field. We're currently estimating that if you purchase our technology, you would have a payback for our technology within 2 planting seasons out there. If you compare that to other, and we're not an inexpensive technology, we are a high sticker price, but the payback in 2 seasons, I would argue, is a much more favorable payback than they could get from other investments on their farm. For instance, buying a new tractor, buying a new combine, even doing tiling in their fields tend to have a payback in somewhere in the 5-year, 7-year time frame for a farmer, but we can deliver that payback in a year or 2 years. So it is an investment, but it's one that's going to pay back for them quickly, and then they're going to see the benefits of the technology. And of course, as we all know, if they can stay in regenerative practices for more seasons than they are today, then they're going to build up the benefits of those practices rather than going back to square one every time they till every 3 years or 4 years.
What is your business model as far as how do you sell this product?
Right.
Sales staff or dealers?
Yeah,
Or
we're still a
what?
small startup, and we're really right now moving from what I would call 100% product development activity. Now we're shifting into commercialization and sales activity. Where the first sales are most likely going to be made directly from us to the farmer
Mhm.
directly. And, to be honest, it's going to be probably those farmers who test our units or their neighbors who see it on the field who would be like the first sales. But the longer range business model is to have a dealer network in place to represent us around North America. We know farmers have their sets of trusted advisors that they
Yes.
use. Their dealer is one, co-op could be another, agronomist could be another. And it seems a little foolish. And from my experience, I've worked in the ag machinery industry for over 20 years. I know you can't replace those trusted advisors. So if we can tap into the existing ag machinery dealer network around North America and have some of those companies represent us in the market, that'd be the way we'd like to go to market.
Right. Well, to kind of wrap things up, when would you predict the first sale?
We technically could take an order today, but realistically, we're going to probably hit the ground running next spring and summer to be taking orders, in the back half of next year. And I'm anticipating, most farmers tend to buy machinery in the back half of the year for tax reasons and other reasons. So it's probably going to be similar for us as well, that we would take orders on the second half of the year, perhaps for delivery for the spring planting season, the following calendar.
Where is your manufacturing facilities?
We are manufacturing. Yeah, we have our manufacturing partner in Ontario, Canada. It's south of Toronto and west of Buffalo, New York. So those companies are manufacturing for us, but we are capable of delivering in North America. Our initial focus is corn and soybeans, perhaps also sorghum, and we're going to be doing some cotton testing this spring as well. So we're really talking about the Corn Belt type geographies, which would be our prime focus.
Thanks to Michael Cully and Dan Crummett for today's conversation. The full transcript and a video for this episode are available at no-tillfarmer.com/podcasts. If you're interested in learning more about Susterre and Aquatill, another company using water jets instead of coulters to cut through residue, join us at the National No-Tillage Conference January 10th through 13th, 2023 in St. Louis. The companies will be there talking to no-tillers about their technology during our Tuesday Tech Talks and an Ahead of the Curve panel discussion on Wednesday. Register online at no-tillconference.com. Many thanks to the National No-Tillage Conference and Yetter Farm Equipment for helping to make this No-Till podcast series possible. From all of us here at No-Till Farmer, I'm Michaela Faulkner. Thanks for listening.